Welcome to Statistics for Surveys, Session 2, Tables, Optional Segment 6, Part 2, Formula for the Relative Frequency. In this segment, we'll try to understand how to create and read a formula for the relative frequencies. It's beneficial if you've had a look at Session 2, Segment 1 about absolute frequencies and relative frequencies in general, and Session 2, Segment 6, Part 1, that you're familiar with how to use the summation sign. So in Session 2, Segment 1, we saw the definition of a relative frequency to be the absolute frequency expressed as a fraction of the total frequency. We can write this in a slightly more textual formula like this, where we actually see similar things happening. As a fraction, that means that there should be some kind of division line, which we have up here, and it's a fraction of the absolute frequency, which is up here, as a fraction of the total frequency, which we have up here. So by definition, we can actually translate that into a text formula. Let's try to convert this text formula into a more proper math formula. So I've listed the formula again, and the first thing we're going to do is we're going to substitute a few of these words to make them a lot shorter. The first word to shorten is the relative frequency. So we're going to be changing relative frequencies into shorten it to RF, and that replaces it like this. For the absolute frequencies, we can use simply F, and for the total number of absolute frequencies, we can simply use N. So combining all of this into one small overview, we now have a lot shorter formula RF equals F over N, with of course RF being the relative frequencies, F the absolute frequencies, and N the total of the absolute frequencies. We could make the simple formula slightly more complex by adding the index numbers, which would be slightly more precise than the simple version. Relative frequencies were RF, so we could actually specify of which particular category that is by using the index. So we get relative frequency of category I would then be RF index I, and absolute frequency F becomes Fi. And if we then substitute these new ones in our old simple formula, we get a slightly more complex looking one with the indexes. In the end, it does the same thing. It's just slightly more precise. Sometimes it confuses students a little bit, but it's actually the same. It's just more precise that you can actually indicate which particular category you're working on. So let's try to reverse engineer so that we can see, if we are given the formula, how we can actually use it to calculate relative frequencies. We're using the table below as an example, where we can see, for example, that 4 students are doing a business program. Now, the first thing we need is the formula itself, which was given as following. And as you can see, there's the i's in it, so we'll be needing the index. So I'll write down the index numbers here, and I'll simply start listing them one by one. So 1, 2, 3, and 4. In the formula, we often see this n coming back up, which is the total of absolute frequencies. So that means to simply sum all of these up, which in this case 4 plus 3 plus 2 plus 1 is actually 10. So n equals 10 every time. So this is what we would call n. Now the relative frequency of the first category is, according to the formula, the frequency, the absolute frequency of the first category divided by that n. So the relative frequency of the first group would be the frequency, which was the 4 of the first group, divided by the n, which was the 10 we previously calculated here. So 4 divided by 10 will give me 0.4. If you want, you can actually multiply this by 100 to get 40%. For the second category, second value, IT, we actually get similarly, we get the relative frequency of the second category is the same as the frequency of the second category, which was 3, divided by 10, which will give you 0.3. Again, multiplied by 100 would give you 30%. For the third category, we get the relative frequency of the third equals the absolute frequency, which is 2, divided by 10, which gives you 0.2. And then for the last one, which is the relative frequency of the fourth category, which will be the 1 of the frequency divided by 10, giving you 0.1. You can do a small check whether or not everything was correct, because all of these relative frequencies should of course add up to 1.0, or if you multiplied everything by 100 to 100%. We could even go one step further by using the formula we saw in the previous segment as well. So far we've seen that the most complex formula for relative frequencies is using those indexes. That makes it look the scariest. But if you look carefully, there's that n again, and in the previous segment we saw that n can also be scarily written like this. So if we combine those two, you can actually also write relative frequencies as shown in this whole formula. So in the end, this might look very scary, but it's actually still the same. It's just taking the frequency and dividing it by the total of all the frequencies.